I don't like these nasty PopUnder ads, and Google Chrome tries to stop them. Unfortunately, some advertisers find bugs in browsers that they exploit to achieve PopUnders. To me, that's like exploiting any other bug for malicious purposes. So in the last video, I reverse engineered a technique that worked on Chrome version 59 and also still worked on Chrome 60 for Mac. And what's super cool is that A.V. Drisman from Google, who works on the PopUnder blocker for Chrome, filed the bug in the issue tracker and is fixing it. And turns out that for Windows this has been already fixed in version 60. So the issue only remained on Mac, but when I visit the demo page of the guy who sells this PopUnder library, then it still works on Windows. How? Remember, the underlying idea for a PopUnder is to open a pop-up and then return focus, get the main window back to the front so the pop-up stays in the background. And the previous technique combined a notification permission request along with a PDF alert to achieve that. But this new version for Windows doesn't seem to use a notification permission bubble. So how the heck does this work? Well, I figured it out so Chrome can fix it. And it's again super clever. Let's head in. I got some great feedback after the last video and tried to improve my techniques on working with obfuscated JavaScript. So if you have more awesome tips or ideas, please share them. One was from Alex, aka InsertScript, who has an amazing blog where he writes a lot about abusing PDFs in browsers. And if you are, like many others, surprised about JavaScript in PDF, then you should really check out his work. He suggested, instead of mirroring the site locally to insert my own JavaScript, I could develop a small Chrome extension to inject a script into every page. This has the awesome advantage that I could inject myself into any iframe that is being created and track whatever they are doing as well. I think that's a much nicer technique, so I started doing that. In the manifest, I declared a script that should be injected into anything, no matter the protocol, domain, or path, and do so before any other JavaScript runs. And this injected script is a content script, which has some access to the page, but not fully. So then I create a dynamic script and inject it into the page. This hook script then does what I did in the last video. It attaches proxies to interesting functions and objects, and later that would be the explorative task of adding and removing proxies as I need them. Then I use window post message to send this debug log to the content script, which is listening to those messages. And in the content script, I take these arriving messages and forward them to the background script. And the background script is always running and can now receive and show all log output of all pages in one place. So a page is loaded, content script is attached to it and executes, inserts another script and uses messages to send it back to the background script. And then you can simply load the extension from a folder in Chrome. When you now have this extension active on the demo page, you will quickly see that it creates again an object tag dynamically with a PDF, and it's basically the PDF we know, it just calls alert. But then I kinda got stuck. The logging output was not perfect. I was wondering if I should improve this extension to log everything, basically create an extensive DOM logger extension with filtering and a nice UI and log property accesses and not only function calls, and that would be an amazing tool to have. But it is a lot of work, so I wanted to try something else. At least we know an extension like this could work and a PDF is involved again. Next I recorded again the PopUnder and slowed it down, because last time it revealed the PDF alert and the notification permission request. But this time it's different. This time it opens a blank tab, then the pop-up which appears in the background and closes the tab again. We don't see the PDF alert because it's just super fast, but when you overwrite the remove child function, making it not work like in the last video, and then do it, you see that the alert is actually there. So at this point I felt I understand the underlying idea of this trick. Somehow you retain focus of the main window when you open a new tab plus using a PDF alert. But when you start trying to emulate that, then you quickly run into the issue that you cannot call window open twice. Window open is used with different parameters to open pop-ups or new tabs, and calling it twice triggers the pop-up blocker, and it will prevent that. You see, pop-ups are only allowed when triggered through human interaction. So for example, when you click, a malicious site would simply overlay the whole page with a click handler, but nonetheless you have to interact to make it trigger. But this also means a single click will only open one window. So how do you do it twice? Open a tab and a new window. So I looked more closely at the Performance tab of the Chrome Developer Tools. There you can click record and then perform actions on the page you want and then stop the recording. Now it recorded everything that happened. This tab is intended to find performance bottlenecks, for example identifying very slow functions, and for our purpose it's not perfect. A lot of information is missing, but when you look closely you can find two major blocks that call window open. This graph is easy to read. Each function call is a bar, and when a function calls another function, a new bar is below it. So the topmost bar is the initial function and the lowest bar is where it ends in. So you see this one block here triggered on a mouse down, and the other one is triggered on a mouse up event. Oh, so that's the trick? Abuse two user interaction handlers that happen during one click to open two windows? Just open a window on mouse down and another one on mouse up? Let's test it. We create two functions that open a new window and declare to be executed on mouse down and mouse up. And when we test it, it doesn't work. The Chrome pop-up blocker is not that easily fooled. Somebody was smart and made sure that that is not possible. But how the frick does the demo do it then? While the Performance tab doesn't have a lot of information, it does have links to the functions in the JavaScript source. Unfortunately, you know the code is obfuscated, and there's a super annoying debugger breakpoint called constantly, which prevents us from debugging with breakpoints. When I initially looked at this stuff for the older video, I defeated this anti-debugging thing by overriding set timeout because a function called with it was responsible for constantly triggering the debugger. But a much cooler JavaScript snippet was posted by Perepsis or WW in a comment on the other YouTube video. The code is intended to be loaded with TamperMonkey, which is an extension that simply injects JavaScript snippets into the site to enhance them. Super freaky script, but in the end all what it does is prevent the demo from calling debugger all the time to annoy us. If we replace the unsafe window with regular window and paste it into the console, we can now simply debug the JS code. So let's go to the Performance tab again and see where the first window open call is coming from. It comes from this anonymous function and it shows us where it is. And Chrome DevTools are awesome. It even knows where in the script it is when we pretty print it. There. So something in there calls open. Let's just set some random breakpoints in there to investigate. Then trigger another PopUnder and the debugger should pause. There we are. Press escape to open the console in the current JavaScript context. So E is just pointing to a window object, and ER is the string close. So this would call window.close. Weird. Let's continue. Always single step forward. N is an array of functions, and QE is a weird function. If we step in it and investigate, it doesn't tell us much. So all I'm doing now is just stepping and investigating the variables. So for example, here is E again, so window, and SI is the string go. So it would call window.go. Weird. That's not a standard window function. But it didn't really tell us much, and also when we continue the script, it doesn't work. No PopUnder. So maybe we screwed up some timing. Let's remove the breakpoint in here and remember that this part wanted to call close and go on the E window object. And then we do it again. So what is this HS? HS points to open. Aha! So that's probably an important window open call. And AO as well as YE are the parameters of it. So about blank and underscore blank. This will open the new tab. And remember that E was a window object that the other function wanted to close and call go on. So that window object was in fact from the new opened tab. No idea why this one didn't trigger first. Continue stepping forward and there we go, new tab. Then UOR is called, which is a weird function with 3 parameters. First, a window object. In fact, this is our current pages window. Second parameter is the string focus. And the third is a function which we know tries to call close and go on the E window, the new tab. I have a suspicion what this obfuscated function R does. T is the window. And Q, what's Q? That's add event listener. So on the current window, it will set an event listener waiting for our current page to gain focus. And then it will call close and go on the new tab. Great. After setting up this event listener, something is called on E again. HI is a string document. So window.document and XI is write. So it will write to the document of the new tab. And there's a long function call as a parameter, but we know it would like to write a string, so whatever this obfuscated code does, it must return a string. So let's just call it ourselves. And there we go. It writes some HTML and JavaScript to the new tab. Let's copy that HTML, make it pretty, and have a look at it. So that defines some variables, a window name and a window parameters, the pop-up URL, as well as the pop-up options, and then it creates a new event listener on mouseup. Oh wait, that's so clever. So the mouseup did not happen on our page, it happened on the new tab. And that's the trick how it opened a second window. Chrome loses track that mousedown already triggered a new window because it happened on another page. And it also registers a new function go to a window, which will simply resize and move as well as redirect the new pop-up window to another URL. That's it. Let's put it all together and walk through it. First, we declare a function to run on mousedown. This function will create a new tab and immediately write JavaScript to this new tab, which will register a mouseup event to open the actual pop-up. And because Chrome is so fast, the tab will be open before you release the mouse button, and thus triggering a mouseup event on the new tab, which will open the pop-up. How crazy is that? In the meantime, the main page also embedded the PDF with the alert, which now triggers and gives focus back to the main page. And that's why we register an onFocus event handler on the main page and then call go on the tab to change the URL to our PopUnder target website, as well as closing the tab and removing the PDF object. And it happens so fast that you don't even actually see it. And that's the magic. Another PopUnder. And it's a beautiful one. I will link the bug reports to the Google Chrome issue tracker below. Also, I would like to mention Patrick, who was also analyzing a PopUnder behavior on iOS and is blogging about it. And he worked with the same script, but not with the demo, but with the script encountered in the wild on 4archive. So check that out.